Hello my dear students, we are discussing integration by perfect square method. Let's take an example. Here it says integral of x cube upon 16 x raised to 8 minus 25 dx. Let's see the solution. Now my dear students, in the earlier module we have understood that instead of x in the denominator we may be given f of x, which is very evident in this question also. My dear students, we will rewrite this question in a particular manner because I have understood and I have observed one thing here very easily. X cube is nothing but it is derivative of x raised to 4 and x raised to 8 can be written in terms of x raised to 4. So the step is, let us write this as x cube upon 4x raised to 4 the whole square minus of 25, which is written as minus of 5 square. As I said some time back, x raised to 4 is the function here and its derivative is nothing but x cube or 4x cube to be precise. So here we have a function, we also have the derivative. So let us write the substitution. Let x raised to 4 is t. So obviously the next step is differentiating, and on differentiating what do we get is 4x cube dx is equal to dt. Here 4x cube is dt by dx. Now we have only x cube dx in the numerator, so let's interchange this 4 and dx. So what we get is x cube dx is dt by 4. What will the integral look like? So can I say the integral will become 1 upon 4t the whole square minus 5 square and dt by 4. Now 4 is a constant in the denominator, so let's write in the next step 1 by 4 outside the integral. What we get is 1 by 4t the whole square minus 5 square, which is very much in the standard form. So let's apply the formula for 1 upon x square minus a square. Now my dear students, the formula is right in front of us. 1 upon 2a means 1 upon 2 into 5. Log mod of x minus a means 4t minus 5 upon 4t plus 5. And again my dear students, coefficient of t is not 1, it is 4. So we have to divide by 4. So 1 by 4 here exactly and a plus c. So now the denominator is 4 into 2 into 5 into 4. That's 10 into 16, nothing but 160. So let us write that as 1 by 160 log mod of. Answer has to be in terms of x. So let us write the value of t, and t was nothing but x raised to 4. So we'll get log mod of 4x raised to 4 minus 5 upon 4x raised to 4 plus 5 plus c. There is no further simplification and therefore we can say this is the final answer. Now what have we in store? There are certain sums which are like this: 1 upon a square e raised to x plus b square e raised to minus x dx. Let's see the solution. Now my dear students, if I copy the question here, very clearly I see a function in the denominator but I don't see any function in the numerator. So my first step cannot be substitution. I need to do some simplification. Now if I think at a very basic level, I understand that e raised to minus x here can be written as 1 upon e raised to x, correct? Or using the law of indices, I can say a raised to minus m can be written as 1 upon a raised to m. So let us do that. A square e raised to x is as it is plus b square upon e raised to x dx. Is that okay? Now the next obvious step is take LCM. So e raised to x will be multiplied here. So what we'll get here is e raised to x upon a square e raised to x the whole square plus b square dx. Now my dear students, there is a function in the denominator and there is a function in the numerator which is its derivative. So we can say that we have a function which is f of x is e raised to x and f dash x is also e raised to x, which is very much present with dx. So let us go to substitute. So let us write e raised to x is t. So the next step is e raised to x dx is nothing but dt. So the integral will become 1 upon a t the whole square plus b square. Now it is very much in the standard form. We'll apply the formula for 1 upon x square plus a square. That's 1 by b in this case because the value of a in this case is b. So 1 by b tan inverse of at by b. Again my dear students, the coefficient of t is a. So 1 by a has to follow. So 1 by a plus c. Now, this can be rearranged and rewritten as 1 by AB tan inverse of AT. We cannot conclude our answer in terms of t. So, we'll write the value of t as e raised to x. So 1 by AB tan inverse of a e raised to x by b plus c, and that's your final answer. Now we have seen two examples where functions were given and on simplification we could substitute. There is some practice required in this type, so these are the questions which you should always try. That's all I have in this module, students. Thank you very much.